Before we jump into closures, I first want to give you a primer broken down in 100 seconds. JavaScript closures are functions that can access values outside of their own curly braces. In order to call a function in your code, the JavaScript interpreter needs to know about the function itself and any other data from the surrounding environment that it depends on. Everything needs to be neatly closed up into a box before it can be fed into the machine. Take, for example, a pure function that only depends on its own arguments and internal data. What we have here is a fully self-contained closed expression. When it's called, it gets pushed onto the call stack, where it's executed and its internal data is only kept in memory until it's popped back off the call stack. But what if that function references data outside of its own scope, like from the global environment or an outer function? That leaves us with an open expression that references other free variables throughout the environment. Now, in order for the interpreter to call this function and also know the value of these free variables, it creates a closure to store them in a place in memory where they can be accessed later. That area of memory is called the heap, and unlike the call stack, which is short-lived, it can keep data in memory indefinitely, then decide when to get rid of it later with the garbage collector. So a closure is not just a function, it's a function combined with its outer state or lexical environment. As you might imagine, closures require more memory and processing power than a pure function, but you'll come across many practical reasons to use them, the most important one being data encapsulation. Closures are one of the more intimidating concepts for the JavaScript beginner, but it really shouldn't be. It's actually a very simple concept. A closure is basically just a function that closes over some state or data so that it can be used elsewhere in the application later. Let's imagine we have a function called outer that has a variable of x. Now, x is only accessible within the scope of this function. However, what if we want some outside code to be able to change the value of x? What we can do is define another function within this function called inner that mutates the value of x. When JavaScript sees a function that references a value in its parent scope, which in this case would be the outer function scope, it creates a closure to save that value in memory so it can be accessed later. What we could also do is make this a higher order function by returning the inner function from the outer one, and that allows us to operate on data inside of this function from anywhere else in the application. In other words, it provides a way to encapsulate data.